technology at all, because I don't see technology as a challenge at all in the IoT space. So we will talk about what is the challenge. The idea is that as you jump into this, either as a startup or as an early adopter within an enterprise, or just from a career standpoint, you need to be aware of these challenges. And that's the whole point of my talk today here, to give you awareness. A lot of these issues that I'm going to bring up are going to pop up much later in the game as the adoption of IoT increases. Utilities in particular happen to be in a unique situation where they have moved on to adopting smart meters, which is kind of a first generation IoT. And they have gone about it at a scale that no other industry has attempted. So pretty much all utilities across the globe, pretty much the entire developed market, are now sold into smart meters. And if you look at shipping or warehousing and logistics, retail, or any of the other sectors, no other industry or vertical has jumped into IoT like that the way utilities have. And I have been the last 4 years working with my sleeves rolled up in the middle of that, trying to figure out a lot of the challenges. And last 2 years have been totally focused on, okay, smart meters are out there, a lot of good data is coming in real time or in near real time. What now? And that's what I've been dealing hands-on last couple of years. So that's what we're going to be talking about. So this is from a McKinsey study that came out in June, and it shows the potential of this market. Does anyone know what the total U.S. economy is in terms of dollars? It's about $18 trillion. And what they're saying is that by 2025, so in about 10 years, you can potentially see an impact of $10 trillion, right? So this is huge. That's like more than half the U.S. economy. No other technology revolution has had this kind of numbers projected. And so obviously there's a lot of excitement, and a lot of large corporations have jumped into this. What McKinsey has done is broken this up into these 9 sectors, and they've tried to, and the study is freely available, so you should download this and take a look at this. It's a very good, very comprehensive initial overview of what the market looks like, where the opportunities are. So everybody agrees on this potential, and you guys are here obviously because you're excited about this thing. But before we jump into that, I want to share something else. Take a look at this statement. Now, this statement is actually talking about smart instruments and machines working with the anticipation of need. So this is the promise of IoT, that all these machines are going to start talking to other machines, and we will have a Cyberdyne system situation from the Terminator series. But the idea is that you get the machines to talk to each other, make them smart, and create value out of it. Now, is this just a fad, just like any other technology revolution is going to go away, fade away in a few years? Or is it real? Is it here to stay? So, can anyone tell me where, does anyone know who said this? Or can anyone pinpoint the decade or year that this may have been spoken? Any ideas?
Middle Ages.
Middle Ages, okay. Well, this is from Aristotle. So if any one of us thinks that we're doing something new, think again. This has been out there. We are only now starting to get to a point where we can actually deliver it and show what this prophecy was actually articulating. Another interesting article that I came across uses similarly prescient language. If you notice, the second part centers around the application of statistical and mathematical methods to decision-making problems. Any ideas how far back this statement goes? Just give me a decade.
70s.
60s or 70s. Okay, so yeah, this is from a Harvard Business Review article in 1958. And the article was titled Management in the 80s. So back then, they thought in the 80s we will be doing some of this. We let them down. So the idea is that what we are doing here is not something new or unique. Only now the technology is there to help us achieve this. The key aspect of, interestingly, this article, since this article, next 40 years, none of the articles within Harvard Business Review actually talk about this aspect of IT. There was a promise of IT at one time. This is one of the first articles in 1958 that uses the term information technology. I have not been able to find anything that earlier than this article. So right from the get-go, this article talks about information technology and talks about statistics and mathematical methods to decision making. And another section of this article talks about the middle managers stepping up and taking more creative functions than they have now, which is more like operations and run-of-the-mill. But we know that Fortune 500 companies or even Global 2000 firms, they are still not, the managers are still not involved with creative functions. They're just doing business as usual. So we let these guys down dearly. So here's a story that I use to kind of illustrate the point. So a travelers advisory group, they got their data scientists together and they brought in a lot of travel data, and based on that they made a prediction. And they said, well, every 10 million flight will have one of the pilots drunk. And when the study came out, airline executives were all worried. People started canceling flights because every 10 million flight will happen maybe every 3 years. That's about how many flights we have in a day. So people started cancellations and looking for alternate routes to travel, methods to travel. So airline executives said, well, this is no good. We need to respond to this. So they hired their own team of data scientists. And they said, well, you need to respond to this study. And so the airline data scientists, they got to work. They looked at all the data. They got their Hadoop cluster working, and then they applied data mining and whatnot. And they said, you know what? Actually, the results are correct. We actually concur with the study of the advisory group. However, we have found something very interesting. What we have found is that there is hardly any probability that both pilots would be drunk. So what we are recommending is that you make it mandatory for one of the pilots to drink. Now, the moral of the story is that it doesn't matter how good your data scientists are, how good your data is, how good your technology is. It's what you do with it that will determine the real outcome of the value that you can get out of big data and IoT. Okay, and that is exactly what I intend to talk about today as to how do you actually address that. So we know, we've been hearing all of this. We've been hearing about a connected home with all sorts of smart devices in a home. We're talking about connected supply chain, smart grid, and the energy sector getting revamped, all sorts of machines and turbines getting sensors on it. So we've been hearing all of that, right? But what does that really mean? Well, at the first level, it means three things. Monitoring. So by putting all these sensors, you have more sophisticated and more invasive capability to monitor any and all things related to these devices or machines or equipment. Then you also have the ability to track various events, react to various events related to a device failure or a device going or a machine going over its established threshold, breaking down, or transactions where you are able to do things because these devices are now smarter. You don't need a person to stand there and things as simple as getting a rental car. You now have a kiosk, and you can go get that done. In a few years, maybe they'll have an IoT device on the car itself, and you just walk out with your cell telling you where the car is that you've just rented. So the transactions are going to be automated, and you can eliminate manual intervention. So monitoring events and transaction, and then of course the performance. So you can actually keep track and see how good you're really doing. The other aspect of this is more analysis on this additional data that you never had before, and then coming up with more actions, more remedial measures. So at the bottom of this, in order for this to happen, you obviously are dealing with a lot of data, a lot of analytics, and then of course you're dealing with decisions. So, I mean, if you look at the literature today in the industry, you will see that there are a lot of ideas like, oh, get all of this data in and then find business insights. Well, what is a business insight? I don't know. I have never seen one. I've been doing this 20 years. It's the decision. That's what you need to go after. And if you can improve the decision-making process, if they can make the right decisions at the right time, that's the key. So I don't even look for insight or a cool visualization. They are all just a means to an end. What you're trying to get to is a decision. And you're trying to get to that decision where you're smarter, you're more knowledgeable. If you're looking to buy a car, if you have not done your homework, if you're not smarter about what cars are out there, how much you can afford, what kind of features matter to you, if that information, that analysis is not in there, your decision is bound to be flawed. So, or the decision would have weaknesses. So in a corporate setting, we are trying to do this as a culture that use the analytics, use the data available to you, so that the decisions that you make as a middle manager within an enterprise on a routine basis, those decisions are much smarter than what you were doing before, which was more like you can just see assess the direction of the wind and try to figure out what you want to do there. So let's talk about the challenges that you're going to run into when you try to do that. So here is a kind of quick rundown. As I was introduced, my background is data. So network and communication, which is a big piece, or the actual hardware design of these smart devices or smart sensors, that's not my area of expertise, but there is a huge opportunity in that area as well. But I've just listed some of those things which are not directly tied to data and decisions, more like deployment. Within IoT, there's two aspects. There's the deployment of the IoT, either a smart device itself, or on an existing device and equipment, you're putting some kind of a sensor on. So we just ran through deploying 6 million smart meters. It took us 3-4 years, and a lot of manpower, labor was required to deploy all these smart meters out there. So that challenge is there, but it's not it's more kind of a mechanical activity. It's just operations, just business as usual. Either get the smart device, or if you already have a device and equipment or factory machines or whatever, get the manufacturer to give you sensors or give you third-party sensors to put on them. So that's not what we're going to talk about. Security is actually a very strong element of this, and because I deal primarily in the energy space now, if you have your machines and your equipment deployed out in the field, and the sensor is telling you it's in good shape, you need some kind of an authentication. You need some kind of a verification that, yeah, it is actually out there, because the sensor may still be sitting there recording to you and the device may be gone, or the device may be tampered with. The idea is that with IoT, you don't need to send labor out there to actually service the equipment or keep an eye on the equipment, whether it's running or not. The sensors will tell you that, but then what if the sensor keeps telling you that everything is fine, where actually it's not? So there is a very critical security element that comes into IoT. Similarly, communication, all these sensors sending all this data, well, how is that data making it into your big data platform or into your data center from your field locations or your work sites? We did a study, so looking at trying to do this over a cellular network, if you are bringing bridges and tunnels data into your data center, monthly cost ranges easily for like a mid-Atlantic states. Monthly cost goes from $30 to $45 million if you try to use cellular. Just network fixed cost that you're going to incur. So obviously you need newer mechanisms to move this data from the field over into your data center. A lot of opportunity for all of a sudden networking communication is sexy again. Cisco is big time jumping into this, Intel, Verizon, AT&T, everybody wants a piece of this pie. Then of course data quality, because you're now going to be getting all this information from devices, from sensors, so you need to, not so much as data quality in the traditional sense, which was more like user errors, that they would put in incorrect data or something like that. Machines don't do that, but you still need to separate information from noise. And then of course, the biggest element of this, the computing platform. Now that you're going to have all this data coming in from millions of these devices, your existing computing infrastructure may not be able to handle this. Well, think again. So we are currently dealing with 1 trillion records. Anyone here has dealt with 1 trillion records in one database platform? Yeah, sounds scary, right? First 2 years, it was very scary, but when the actual data started to come in, we were like, what, really? And this is something that none of the big technology companies are ever going to tell you. Here's the truth. So if you look at the devices on the left-hand side, and you look at the data on the right most column, you will see that even though the number of records looks scary, the disk storage or the processing that you actually need to handle it is not scary at all. We routinely deal with this kind of volume. So 4 terabyte for 1 million devices, right? Sending data every hour. And a lot of these, even though I've put down 40 bytes as a record size, most of these sensor-based data sets are actually very, very small. There's a very simple log with maybe 5 fields, 20 characters total. So 10, 12 bytes, if you have a way of compressing it to move it around, even smaller. So the big data platform is not the challenge. We can handle this type of data, no issues. We've been doing it for a number of years. Your Oracle databases, your SQL Server databases are fine. You don't need any fancy database platform to handle this kind of volume. We haven't had a need. We've got vendors up all over the place trying to sell us all kinds of technology platforms with our smart meter, 10 million smart meter project. And we were like, okay, show us give me a business case, give me a need, and I'll buy it. And I haven't seen a need, and they have all been very, very disappointed that this is actually not as big a problem as they thought it was, at least for the smart meters so far. Okay, so, but even if it is, if you need like a high-end big data platform, the progress that we've made in the last 3 years is actually tremendous. So it's not something that you need to be scared of, it's just something that needs to be done. So I still don't consider it a challenge. So what is the challenge then? I mean, if the data is not a challenge, if the network and communication, there are ways to handle it, then where do we run into trouble really? And that's where the business case comes in. How do you promise to your business that you have a problem that can be solved by IoT and big data investment? So in a traditional sense, when we talk about innovation, there is product innovation and there is process innovation, right? So product innovation, Sony used to be the kind of the poster child of that, and last few years it has been Apple, and it doesn't look like Sony has that traction anymore. But still, there is the creative or the artistic element of product innovation. Then there is the process innovation where you deal with operational excellence and interaction with a customer. So this IoT applies to the operational excellence part of it. I haven't seen a use case or a proven demonstration where investment in IoT analytics has actually helped with product innovation. Maybe there is a case out there, I haven't come across one yet. The McKinsey study, if you look at it, everything is around operational excellence, optimizing. That's the key word for IoT analytics. So in terms of that, what I highly recommend is that you look at how the existing value proposition is working within a certain operation, and you try to figure out how you're going to complement it, rather than trying and revolutionizing how a business is run. So the business is running today, right? They are doing the things that they need to do to be profitable and to be efficient and to be make the shareholders happy and Wall Street happy. All of this is happening today. It's not that we're in a vacuum. So with IoT, what are you going to do? Well, you're going to improve on that, okay? So don't try to create something new from the start. Try to first augment what is already working. So you align yourself with what's already out there and show value just by incremental improvement in that value, which everybody currently understands. So if you're going to just change it dramatically with a new value proposition for IoT, the current world functions like this, and all of a sudden you're going to offer them this, they're not going to understand. The shift is just too much, and it's not going to happen. And then we'll look into that much deeper. A word on what is analytics. So about 5 years ago, the term actually meant what it means. Now it's no longer the case. Everything under the sun is now analytics. So I try to stick to the original definitions and the conventions that have been out there for a number of years, 30 years actually. So quants, actuaries, cybernetic, sabermetric, as well as there's a term in the healthcare, they will use analytics, the informatics. That's the term that healthcare uses. So they all refer to the same thing. So the idea is that towards the bottom, what do you do with the data? This information continuum shows how do you evolve getting value out of data. So at a bare minimum, what do you need with the data? You need to search. You have a customer on the phone, hey, I'm this, this, and this. You need to quickly search one record at a time. So that's like the most basic function of getting value out of data. And as you can see, the business value is towards the very low end. That's not going to revolutionize your business. You're just able to search, but that's the foundation, the first step. And then you incrementally build on it. So operational reporting, counts and lists, search and lookup, these are pretty much now part of your operational systems. These are part of your ERP system. They're kind of embedded and included in there. Then you start to move into, okay, but that actually tells you what's happening now. How are you doing? How is the business doing right now? There are ways to figure that out from the data in your operation systems. Then the idea is that you move further up from that and you start to accumulate this data over time, and now you have some historic trending and some patterns which you can see to assess how you have been doing on your business. The analytics piece up top is dealing with the future. That's like, what do I do next? So if anyone says that, well, you look at some reporting and this is analytics, well, no, that's reporting. That has been out there for a number of years. That's your BI. Leave it as it is. Don't change the definition. Only deal with analytics when you are moving into the future perspective. So as we go through this, you will see that my definition of analytics kind of pushes towards the very higher end of this continuum that analytics deals with what do I do next. What I've already done is part of your BI and your business intelligence data warehousing type of thing, and it has been going on for a number of years, so no need to disrupt that. So what is this analytic model and decision strategy? Well, we'll come back to analytics models in a bit. Let's look at the decision strategy, because my entire focus is that you gotta help them take better decisions. That's the idea, the promise behind IoT. So this is an example of what we call a decision strategy, and that's why data scientists, like 20 years ago, this was called decision sciences, and then it kind of just evolved, but it was all about taking smarter decisions. So Google still has a decision sciences team. They've got like 40, 50 PhDs in there in one centralized team, and YouTube and Google News and their ad, all of their products actually use this centralized pool of intellect and collateral that they've accumulated over a number of years. That's kind of the brain trust of Google, and they still call it decision sciences team. Okay, so the idea is that you build a predictive model that, so you have all these devices out there in the field, and you've got sensors on them, and you are kind of constantly tracking their data and their performance. And based on that, looking at historic data, you've built a predictive model that predicts the probability of a device failure. So the model is in the first top box where you actually predict the outcome that, okay, there is a probability of this device failing, and you run this on each device. So if the probability of a device failure is greater than 87%, then you look at the last maintenance, right? And if the last maintenance was in the last 3 months, meaning you fairly recently serviced this thing, and the age of the device is greater than 5 years, then your action is to replace it. If the probability of device failure is less than 61%, then it's too low for you to do anything. You don't want to unnecessarily fix something that is not going to break, so no action. And then if it's between 61 and 87, then what you do is you look for a nearby schedule, somebody who's already in the area, and if there is somebody in the area, then you add it to their schedule that, hey, while you're out there, repair this device or do a maintenance run on this device as well. But if there is no schedule, then you let it be. If it fails, there's only so much you can do. You don't have unlimited staff, you don't have unlimited resources. So you got to make decisions where you're going to deploy those resources for the maximum throughput to your organization. This is a type of a decision that a shift manager or a dispatcher is making these decisions day in, day out on a regular basis. They know how to do this, they've been doing this for a number of years, so what you are trying to do is now help them with data-driven or analytics-driven capability to do the same thing. So is this starting to make sense actually what I'm talking about in terms of decisions and how analytics is complementing, because the maintenance is going on today. It's not that you don't have devices out there. You have a crew, you have equipment, you have staff, you have repair parts, spare parts, and you have a dispatching system that sends people out and they go out and repair. But what do they do today? In the non-IoT or non-data-driven environment, they go with what? So could be because of customer calls, the customer saying that it's broken or it's not working, come help me, that's one. If the customer is not calling, then what are you doing today in the non-IoT data-driven environment? How is a dispatcher sending engineers out there to repair or maintain? It's some kind of a round robin. It's anecdotal, fixed schedule has been going on. Okay, every 3 months you need to service this. Okay, why? Why does an oil change have to be 3,000? Has anyone looked at it? That no, the way I drive, I actually need it done after 5,500 because I'm a very conservative driver. My wife, very aggressive driver, she may want to change her oil every 1,500 miles, right? But we don't have that level of intelligence to optimize our decision, to optimize our resource utilization. So what we go with? We go with a broad stroke, 3,000 miles, everybody has to change their oil, right? That is where McKinsey is coming out with these value propositions in the $10 trillion numbers, that every decision that an organization is making is probably based on years and years of anecdotal information, subjective and experience-based ideas. If you complement that with IoT and big data analytics, you can really optimize the resource utilization and make money along the way, or save money along the way. Okay. So I'm going to speed it up a little bit. So I have a kind of a use case that I'm going to go through, and then you have been given a kind of an exercise where 3 more use cases are in there that I would like you to kind of just think about, do a little bit of paperwork, and then we'll discuss in an interactive session. So this is also from the McKinsey study, and it was a big help. It came out in time. I've been every month I'm speaking on this topic, and their material greatly helped me put it together in a concise form. Otherwise, putting all this material together in my spare time is very painful. But anyway, so the idea is that this is the next generation retail store. And trust me, I'm telling you, I mean, everybody thinks retail is dead, brick and mortar is dead. Think again. There are so many cool things happening. Brick and mortar is going to be sexy again. The experience of online shopping cannot come close to sophisticated retail experience that an individual can get out of brick and mortar. A lot of the malls are adopting this. A lot of this is real. This is not pie in the sky type of stuff. So the idea is that you have automated checkout. That's probably the most simplest one, that you can just do it on your own. You pick up the merchandise and you walk out, and your phone or your smart pay mechanism and your scanner that scans the ticket, the tag on the merchandise, or maybe there is a small IoT on the device, on the merchandise itself. So self-checkout, that's obviously there. But then a couple of very interesting ones is the layout optimization. How do you design your shelf space? How do you design your floor space? The real cool stuff happening over there using big data technology. Similarly, monitoring the customer interaction through using video cameras. All departmental stores have video cameras, but they're there for security reasons. Well, they've got tons of great footage, and now you have the technology to quickly process those video footage and extract more value out of it. What can you do with it? So on and so forth. So, but a retail store today is functioning, right? A retail departmental store is functioning today. It's not that they have closed down doors and only when we do all this IoT cool stuff, only then they're going to open. So if you were to take a retail departmental store to this level of sophistication and optimization, what are you dealing with? Okay, so here is a very simple org chart of that departmental store, right? So you've got a CEO, you've got somebody responsible for the store operations, laying out the floor plan and the facility itself, and then the actual sales of it. So, and then there is the supply chain. How do you get all the product onto the floor? And then, of course, there's a lot of marketing where you get to the customers or interact with the customers. So, if this is your existing org chart, very simplistic view, and you can pretty much put together this type of org chart for any organization, because you do understand that, yeah, okay, there's like 4 or 5 key functions. Each of them has a VP or a director heading that, reporting up into the senior executives in a company. So the functional breakdown of a large organization is very much aligned with their org charts. So looking at an org chart can tell you how the organization is functionally organized. Now, some of the business processes in there, of course, there's procurement, distribution, merchandising, advertising, direct marketing, warehousing. All of that is part of any retail front and back office operation. So you're dealing with a whole bunch of business processes. So you're dealing with a corporate hierarchy, you're dealing with a whole bunch of business processes. Then, obviously, you're dealing with a whole bunch of systems, right? And you have a procurement system, and that system is actually a cloud-based vendor that you use their technology, and on a nightly basis, it takes your inventory, it takes your sales data. Based on that, it kind of does some demand forecasting and puts out the procurement orders to the manufacturers who ship the products to you. So, similarly, each of these business functions have some kind of a system that is automating them. So with the business processes well established, well documented, everybody trained in them, systems that support those business processes, and the org that actually owns and is accountable for that business, for those business processes. That's what you will find in any large organization already working, right? So when you try to go and do this, that hey, I'm going to revolutionize your retail environment, and I'm going to make it very cool and hip, and you can do all these great things with this new IoT deployment and decision making. So what do you think is going to happen? Each of those business processes need to be relooked at. right? Google business process reengineering and see how complicated that is in a large organization. It's not easy to change a business process the way they've been doing things for a number of years. Similarly, if that system is used to doing nightly price computations or nightly inventory computations, with IoT, you're sending it real-time data, that system doesn't know what to do with it. So even though you have a very nice sophisticated IoT deployment out there and you've got cool data coming in, the system which is actually going to do the pricing on the products cannot take that data in. It was never designed to take that data in. So you will have to revamp that. Yeah, good luck with that. Your IoT project is going to sit on the shelf while you take 3 years revamping that system to now step up to real-time decision making or near real-time decision making on pricing. So that is what's going to slow you down, not the deployment of IoT or not the cool data that is coming in. And you cannot do it either or as well, because you can say, okay, well, I'll let them function the way they are, and then we're going to do all these cool things with IoT. No, there is one GL, there is one financial system, there is one order processing system. You cannot create an alternate universe within an existing enterprise because you are dependent on the same manpower, same facilities, and the same set of systems to get things done. You will have to revamp all of that in order for this to actually take a hold. That is what the challenge is. So it has to be tackled head first, very early in the project, to set the expectations. If you are an entrepreneur looking to build a product in the IoT analytics space, when you go to your client, this is the first thing they're going to ask. That, yeah, this is all nice, this is going to do great things, but I have this 20-year-old mainframe-based system, that's where I do all of this. How are you going to get this cool ideas in there? And you will have to address that problem. If you cannot address that problem, they're not going to take your product, no matter how good it is. Or if you are already part of an internal organization and your organization is looking to jump on some IoT pilot projects or analytics projects, it will be your job head first to deal with this situation, that once the good data starts to come out, once these decision-making metric or rules are starting to come out, where are they going? Because if you are taking them back into your SAP ERP system that you purchased 7 years ago, forget that. It's not happening. That system cannot step up to accommodate this type of data and this type of decision making. First of all, a lot of those operation systems don't have a decision making engine. What they have are workflows, and user sits through the workflows and takes the decision. Now you're saying the user needs to be taken out of it because you can make these decisions on the fly, machine to machine interaction, so you can take those decisions on your own, in a semi-autonomous manner. So that functionality was never built into your operation system. They expect a user to say, send, do this, buy this, sell this. So now all of a sudden you want it to be automated, you will have to rewrite that system for it to work. Okay, so one of the other challenges is the data sciences challenge. So again, McKinsey back in 2010 came out with a study, and they said, well, we're going to need like 500,000 data scientists or something like that, right? And I challenge that assertion as well, because what I have seen is that data mining comes to your rescue tremendously. And if you see on the East Coast, particularly New York, financial sector, healthcare sector is all statistics based. And training a data scientist in statistics and in data, the learning curve is tremendously difficult. If you want to have 10,000 data scientists on the statistics side, extremely complicated. If you look at the West Coast, LinkedIn, Google, Facebook, they never went that route. They saw the limitation of that from the financial sector. They directly jumped into AI. And they said, well, we'll let artificial intelligence sort this out. The learning curve over there, extremely steep. Immediately you've got staff ready to roll with the data and decisions using data mining. So here's a very simple example, right? So here are your billion row data set, and if any one of you are not familiar with predictive modeling, this is kind of just a quick 101. I'll spend a minute on explaining this, and it is actually that simple. I've got several offshore teams where 3 to 5 year of programming experience is all I ask, and within 6 months we are ready to build models, test models, tune models using open source data mining tools. So I don't believe that's a bottleneck or a challenge that we cannot very easily surmount if we move in the AI direction. So this is your data, historic data. So you've got age, income, student status, and the credit rating, and then you have an actual decision whether somebody bought a computer or not. So this is kind of your retail sales data on a computer sale that you've pulled out from your data warehouse, right? So what does AI model do, like a decision tree predictive model? This is what a decision tree I have found to be the most useful because it visually represents a tree, and if you see a tree totally skewed in one direction or one leg holding all the data set, then you know something is wrong and you need to spread it out. The moment you can visually spread out a decision tree in a more kind of a equi or a balanced approach, then you have a good decision tree predictive model ready to roll. And on any new data set, it takes maybe 2 days to get a predictive model working with the decision tree. Just because of its visual appeal, actually. So what it does is that the data mining algorithm for the decision tree actually looks through or sifts through that historic data, and it says, okay, so if age is less than 30 and student is yes, then they buy it. So the net result is you're trying to figure out what's the best path and what's the common path when somebody buys and somebody doesn't buy. So it looks at the historic data, learns from it, deciphers the pattern that, okay, if this happens, this happens, this happens, this guy buys it. If this happens, this happens, this happens, well, he doesn't buy it. So now it has deciphered a pattern out of it. It converts that pattern into an actual tree like this, and now you know that if you are a student who is 18 years of age, are you going to buy or not? So age is 18, so you are on the left leg of this tree. Student is yes, so you are on the right leg of that, and then the buy decision is yes, so that means you will buy. This simple visualization can actually help your sales staff where to focus and where not to focus, or you can convert this into some kind of a probability number or a score, and they can look at the score and decide whether they're going to pursue this deal or not, because the customer is unlikely to buy or very likely to buy. So this is how it works. So you first train the model. You have a variable where buys computer. That's what we call the predicted variable. And in historic data, you already know what the values are. In new data, when a customer just walks in, you don't know whether they're going to buy or not. So what you do is you take the historic data, you apply the decision tree algorithm on it, and now you have a model. So once you have the model ready, now you have the biased computer. You don't know that because now somebody has walked in greater than 40 years of age, medium income, they're still a student, and they have excellent credit rating. So what do you think? Is he going to buy or not? First customer. We don't need to answer this question anymore, right? Because if someone is over 40, still a student, what's wrong with it? What are they studying, right? Are they serious about buying this computer or what? So you can take all the subjectivity and the human element out of it, because the tree, your decision tree already will take the decision for you. So now you don't know the predictive variable, it'll pass that data up to the model, model will send you the decision back that yeah, he is going to buy or he's not going to buy, right? So now you are taking all the idiosyncrasies of human activity out of it, and you're letting the system do it. Now, what does that mean in our retail example, right? So in a retail example, we actually build a real order quantity probability. So now that everything is tracked in real time with IoT, assuming the case study that we were talking about, that this retail store goes all big bang IoT, everything is now connected, everything is talking to everything else. So now you know exactly when your inventory is going to run out, right? So this is the predictive model that you build on it, that you've got real-time IoT data coming in, and based on that you're trying to figure out that what's the probability that my inventory is going to run out today, right? So if the inventory of running out is greater than 87%, then you're going to look at the demand. Do you need to order more, or some kind of promotion is already done? If the promotion is done, then it's very unlikely that the demand is going to sustain, so maybe you don't need to order more. But if your promotion is continuing and the next shipment is 10 days out, then you have a problem, because a lot of customers are going to be coming in asking for that product, and that product is not going to be there. So you just reorder. Similarly, if the probability is between 87 and 62, then you say, you know what, let me just check a neighboring store. If they have some excess inventory, I'll request a delivery. But if it's not there, then it's not there. I mean, because the probability is kind of middle of the ground, 62 to 87, so it may finish, it may not exhaust. So I can live with that risk. I don't have unlimited resources to order more product. So this decision making today is happening on a very subjective level, where first of all they don't have the actual counts available to them, how much is remaining on the shelf. Only towards the end of the day they actually count and make an inventory note that, okay, this is how much we sold today. So their sales system and their inventory system may not be linked, may not be talking to each other. With IoT, machine to machine talking, they're both talking to each other. Everything getting sold, IoT knows that, hey, this thing moved off of the inventory, or it has a sensor on each product, so it knows it came off the shelf and got out the door. So you have real-time information on the inventory depletions, but your decision making is, so that is why you can convert this decision making into a automated process. Okay, so here's the, I mean, like in a retail operation, monitoring of activity, like how many customers are there, any of the tills or any of the point of sale need because if you know, in a large department store, not every point of sale is manned, right? Only when you start to see more people in that area, the manager sends somebody, hey, go open up that register because there's like people in the area. So it's mostly manual, the monitoring. Similarly, your monitoring of the product movement is also manual. There is some digital recording of information. You do a lot of statistical sampling. When you set up aisles and you set up displays, you only do a very small sample and try to figure out whether it's going to work or not. But there are still established reporting frameworks. So management in the back office is looking at this data on a regular basis with well-established reporting infrastructure. And then they also know how to give reward to your store manager, right? So we originally in the IoT promise, we looked at these three things: monitoring, events and transaction, and performance, right? So now events and transaction, they pretty much, most events and transactions are kind of automated. They may be in disparate systems, but they are automated. And then years of complex integrations have gone into bringing them together. A lot of it in the retail is happening in batch, and then there is an established incentive and reward mechanism. So if you do run out of inventory very frequently and you are unable to reorder, that looks bad on you as a store manager, and that will get highlighted in your performance review at the end of the year. Similarly, on the performance side, it's very subjective. It's based on predefined reviews and schedule changes, like the 3,000-mile oil change. When do you change a display? Well, okay, it's fall, so I'll go and change all the display. So it actually works on a calendar. Nobody looks at it more closely to actually see whether people are looking for fall clothing, or are they ready for fall clothing, or if you try to go buy a ski glove in end of January, you will never find it, because they stock them in September and October, and by January they stop ordering them, and whatever is on the shelf is all you've got, and once it's finished, it's done. Well, maybe it's winter, another wave hits in February, and there's a lot of snow and people want to go out and ski, but then absolutely nowhere would you find a ski cap or a glove. So that's the type of anecdotal decision making that we are challenging with IoT and big data analytics. So with IoT, it's fully automated, real-time reporting. You need a new technology infrastructure. You need a new reporting and metric adoption, because now you are getting measured on different things than you were before. And then of course you need new decision-making thresholds. What are these thresholds? It's like, well, if the inventory is below 50 quantity, then order more. Well, why? Maybe the 50 is actually going to last 3 more weeks, so I can wait to reorder for 3 more weeks and save on my cash flow. But you don't know that, right? So now you're going to say, okay, the new decision making is based on a predictive model rather than an anecdotal decision metric that, okay, if it has hit 50, I need to reorder. So from that mechanical activity, you are getting smarter. Your average floor worker is now becoming a knowledge worker. Knowledge worker is, the way I look at it, is not someone who's able to bring all the knowledge together and find interesting things out of it. Knowledge worker is someone who can easily take the knowledge and put it to work. So you take decisions on that knowledge. The challenge is you have to simplify it for them. They're not going to go to school and get a degree in statistics to actually go figure it out on their own. It's our job to simplify it for adoption. Okay, so legacy systems, of course, you can't change these processes to real time. A lot of this is operating on batch today. And then you can't partially redefine the business rules. Either you upgrade all of them or you leave it alone. You can't mix and match. Now this is an article that came out a couple of years ago, and unfortunately it's not an article that was that I've seen a lot of traction on, even though what it's highlighting is that if you take IoT or big data analytics project and you hire a team of data scientists and you look at some very interesting business insights on which you're going to revamp your decision making. The case study that they put in the article, this is a HBR article, what they put in there is that a bank hired a team of data scientists, invested in a big data platform. What they wanted to figure out is how and where to deploy ATMs. So in the non-analytic environment, deployment of ATMs is a subjective decision. Oh, there's a mall there? Okay, let's put an ATM there. Oh, there are a few shops there? Let's put an ATM there. But they wanted to go about doing it with a little more sophistication. So they brought in a lot of retail data, a lot of sales data from the market, from the industry, and they tried to figure out how do we decide where to deploy the ATM. So they spent close to, I don't know, $5-7 million on that project to figure out that one question, where to deploy the ATM. And even before they were ready to deploy, so they solved the problem, they now knew what they want to do. They were now taking that information over to their ATM field staff that, hey, we found this, use this from now on, so you know where to deploy the ATMs. Before they were doing that, the consulting firm that was engaged with them took that knowledge, that information, to the competitor and pitched the same value to another bank. Hey, if you want to know how to deploy ATMs, we can show you how to do it. So the idea of the article was that you cannot protect these innovative ideas or insights that you're going to come out with your investment in big data and IoT. So if you can't protect them from an IP standpoint, that means competition is going to be right behind you. You're going to like the McDonald's versus Burger King anecdote that we always hear. So McDonald's spends a lot of time in real estate analysis and they figure out what's the right location to open up a McDonald's, and then Burger King just looks for a McDonald's and opens next door or across the road, right? So someone is taking the pains and making the investment, and someone else is just getting value out of it without that capital investment. So everyone is going to wait for someone else to do it because then I can very quickly copy. So what is the competitive edge with IoT and data analytics then? Well, why bother doing it? I'll wait for my competition to do it, and then I'll either hire one of their managers or their consulting firm or buy the same technology that they've bought. So why do I go through the learning cycle? Yes? Sometimes the innovations catch on very quickly. Yes, so the idea is that if you create a culture around this, if you create a culture around every single business process that you can optimize and tune, and your line managers are able to quickly learn from historic data and real-time IoT data and take decisions on it, if you can create that culture, then nobody can match that. Because every single innovation that you're coming out with, yeah, they are copying, but there's a 3 to 6 month lag in their copying mechanism, right? You are churning it out at such a fast pace that nobody can keep up. That is the competitive advantage. So in order for that culture to take a hold, you got to make it simple. You got to break it down. And then that's a technologist's job. If you cannot break it down, if you cannot simplify it, then they're not going to adopt. If they're not going to adopt, you're not going to get any traction. But if they adopt as one off here, one off here, one off there, very quickly it'll get copied. You won't get any competitive advantage out of it. Right? So let's. Anybody has any questions on this topic and around it? We can then jump into the exercise, and we'll have a good interactive dialogue in the next 20-25 minutes. So I'm open to any questions. Yes. Okay, so the question is that I mentioned that the communication challenge is there, but it's manageable, it's doable. And then I showed some numbers from our 10 million smart meters with 4 terabyte of data. So how did we resolve that? So that 4 terabyte of data is on a 1 or 3 year history basis. The communication challenge is bringing every single record in, right? So the networking communication challenge is not on the volume, on the data size, it's on the velocity of it is the challenge, because every machine or every sensor is sending it in at the same time in sub-second or under a minute time frame, so you need to bring all of it in. So the size may not be a problem unless you are accumulating it in the field somewhere, compressing it and then moving it back, which basically means it's an hourly or a nightly operation. You're not really getting real-time information. In some cases, it may not be practical to actually do it. But the communication challenge is more around if you have it really spread out in the field out there, if you're in the railroad, transportation, or something like that, then how do you get each of these individual sensors to send that data back to the data center? So that 4 terabyte number doesn't apply, because that's where you're accumulating information, and over time it becomes 4 terabyte or 10 terabyte or whatnot. But that's not the communication issue. Does that help? Yes?
How do we respond to those who challenge IoT, thinking that the social consequences of investing in IoT will affect the average job market?
So the question is that there's a social labor impact to IoT that, as I just described, that if you're taking all this decision making out of a manager's hands or field workers' hands, and now the system is telling them what to do and they're just going out there and doing it. So what's the labor impact of that, with the low-end jobs actually going away, replacing by automated machines or machine-to-machine interactions? We can take this offline. It's a big topic. This last month's Foreign Affairs magazine and Economist and a couple more magazines. There are at least 6 articles that back-to-back came out addressing the same issue in July and August timeframe. So I would strongly recommend that you do that, take a look at that. But bottom line is that the conclusion is that you cannot stop technology because you're going to lose some jobs, because newer types of jobs are going to come in. For example, network and communication sounded like a dead career, right? You go there, you operate a few routers, and a lot of it is getting automated. You just sit there, dead-end job, not going anywhere, not exciting anymore. Well, guess what? All of a sudden, it's exciting anymore. There's a lot of investment going back into the foundations of communication technology. What do you do? And it's going to be hot and sexy again. So
So every new innovation is going to impact some legacy jobs, but it's going to create newer types of jobs and newer kinds of business models that didn't exist before. So customized product building is one of them that has been touted a lot, that now you don't need to build a standard spec. You can now build a custom spec for every single individual. So the concept of assembly line is going to dramatically change. You're not cutting the same cloth now. You're optimizing and you're tuning it for it. Yes?
You mentioned that you use some open source analytics tools. Will you share what?
Sure. So in terms of open source analytics tools, I would say 9, K-N-I-M-E, 9. And there is one more. It'll come to me. But there are a couple of data mining tools that have been out there since the 80s. And when AI was like really, really sexy and hot, but the technology in terms of data storage and CPU wasn't there, and it would run for hours, and it was just impractical to do anything meaningful using that technology. Same tool sets have now matured tremendously, and with the computing power now at our disposal and the data sets now at our disposal, they can do just wonders. So the one I extensively use is 9, and it's a limited license. I mean, if you actually use it for commercial purpose, there's a small chunk of change that you pay into the overall open source project. But for R&D activities, it's phenomenal. You can download it, download some data sets. There are a lot of data sets on the internet as well. Download a data set, download 9, play with it on your computer. I can assure you that if you have a basic Visual Studio type of development experience and knowledge, you will quickly figure out how to get this thing to work, how to process data through it, and how to create models out of it. K-N-I-M-E, 9. Weka is the other. W-E-K-A. Yes, anything else? Anybody? All right, so let's do this. So the exercise that I kind of put together is there are 3 business problems, and I would like you to address the org chart, the existing business processes, the existing systems, and what kind of predictive model or what kind of analytic model would you put together, and how that would help the organization, how you would circumvent or overcome the challenges that we kind of talked about over here. So if you can split up in 3 groups and take each problem. So I would suggest if you can just simply kind of do it this way, so till about you being the line here. So everybody on this side tackle the first problem, then everybody in the middle here, you can look at the second problem, and then everybody kind of on this side, left side of the room, you can look at the third problem. Everyone has that document, right? Is there anyone who doesn't have the problem statement? Okay.
I thought it was distributed to everyone. Let me actually put it up here. I don't think that's actually going to work because it's a document. I'm not sure if they put it out there, but basically
It was part of your bio on the website.
I'm sorry?
It was part of your bio on the website.
Was it?
Yeah.
Okay. So hold on, let me just try and figure out what happened here. This thing died for some reason. Oh, there it is. Okay, so this is basically.
Your microphone is off.
It is on actually, and. Everything looks good here on the, everything looks good here. I'll just try to speak a little louder, I guess. But basically what I'm suggesting here is that you do these 3 things. You kind of look at the org structure, what you're going to be dealing with, what type of IoT deployment would you do, right? Then jump to a predictive model. We can skip, in the interest of time, we can skip through the data aspect of it. So what kind of model would you build, and what kind of decision strategy would you build, and then what kind of organizational impact would you have, right? And how will you determine the value proposition that you can. So let me just get rid of this part here so I can increase the size a little bit. Okay, so this is what you're looking to do on this, and the 3 case studies are. So one is utilities, device outage. So you have a power infrastructure, and all the devices out there. So what happens is that if the customer calls and I don't have power, then the utility starts to figure out, okay, why don't they have power? And if 20 customers have called, they try to figure out what's the common denominator in terms of how the power is supplied to them. Maybe that's where the problem is because everyone is complaining. So they do it today from inference and subjective analysis. If every single device, like a meter, transformer, feeder, substation, poles, everything that the smart grid has IoT on it, then how would you change the process, right? How would you know something is out? How would you dispatch somebody to go fix it? That's kind of the first problem. The second problem is dealing with like a forklift or a warehouse hand truck, cranes, those kind of things. You have that equipment, you are warehousing and inventory or like a transportation company. So you lease that equipment, it's deployed in your facility. If you put IoT sensors on those machines, what does that do for you? What kind of value can you extract out of it? And then the third one is auto insurance. And I've picked up very simple use cases that we can relate to in our daily lives. So auto insurance is that they're saying, well, put this sensor in the car so we can carefully track everything that the car does. So how would the insurance use that? What are some of the challenges they're going to run into with their existing processes, and how they will get value out of it? So this first group on the right side of the room, my right side, you're going to deal with the utilities and the device outage. Then in the center here, you guys, if you can tackle the forklifts and cranes, and if you put sensors on them, what kind of value you can get out of it, or what kind of disruptive business issues you're going to deal with. And then the group on the left, including anybody up top here, if you want to tackle the auto insurance with the IoT sensors in the car, what happens then? So the 3 questions essentially, just further simplifying this, that you're looking to answer are organizational impact, what kind of value, and how do you make a business case to the management that the change is actually warranted. We'll give you about 10 minutes, and then we'll discuss, and then we'll close.
All right. Works of energy.
Yeah, feel free to hang out and like work on it together, or.
A grander vision.
you're a good driver.
So I guess the art part here isn't actually visual mind. How it works for us, each has a branch structure, three nodes that can go out and have multiple guys who shoot
But it also gives them so today they have
Nice to meet you. Are you next? Okay, I am going to actually
by having data on customers, they might be able to correlate their driving patterns to something else, give them a more accurate model that they can apply to the others. We're not using right, so it's a big correlation question. They have to be not very good. That will improve their correlation so that you're right, the better drivers a little bit less, but the worse drivers a little bit more. But that's good for the insurance company because it's more accurate for the cost. Right, so our friend here was a bad driver. He would use that for 2 months, find out that his rate goes up, and he would leave Progressive or whatever.
Now we have, so that's what
What's the provide for implementation? What are the challenges that
So, all right, so in the interest of the next session, speakers already here, we're going to try and wrap it up or speed it up a little bit. I apologize for that. This requires a little more time and a little more discussion. But in the interest of time, we'll try to speed it up so if you can take your seats again and we'll just quickly go over a few
important aspects of each of these exercises. So the first one was that you have all this physical infrastructure as a utility, and if you were to put sensors on all the poles and transformers and feeders and all of that, what does that do for you? So I'll ask any one of you or some of you to kind of just explain what kind of value proposition can you get out of putting IoT sensors on your physical infrastructure?
I guess our first thing is it allows you to you can visualize a branch, you can visualize the trees and each of the nodes being one of the items on the IoT, so you can find your root cause of the problem very easily. And then for each of those different nodes, you can assign them a certain score for how many people are served by it, so kind of utility score for that node, and then maybe a cost for fixing, average cost for fixing that node, maybe a safety score you could add in that as well. So by addressing each node individually, you're able to affect your deployment and the need for that node.
Okay, so everybody followed what he's talking about? Because now you have a visual representation throughout your entire infrastructure, and you can actually see that, okay, if there's an outage here, customers here, here, and here, then you can trade it back to where the actual problem is. So you have better monitoring capability, you have more granular tracking and ability to monitor, and then also your maintenance schedules, you can optimize those as well, because the entire network is in front of you visually, so the human decision making of what to do where dramatically improves. Now the second question on that is that with your existing processes of doing that today, what kind of change you're going to incur? Because you have a dispatch system, you have a maintenance crew, you have all of that set up today. How is that going to change now?
We are going to respond to alerts to servers or something like that, and it's not going to be case basis, it's going to be more like failure basis.
Okay, so then the dispatch system probably may not need to change. It's just that the identification of an outage is coming online in real time rather than somebody calling. But the thing to watch out for here is that what if it's a incorrect, like a false positive. So your device is saying I'm out, but actually the sensor is out. Device is fine. And now you've got your crew dispatched over there, they go there, they waste all this time, and then they realize, oh, actually the sensor was bad. So that is something to look out for. That's a new business process that you need to incorporate in your existing activity. Okay, I'll cut over to the next group. So you were dealing with the cranes, forklifts, any warehouse equipment that you may have running your operation. And your operation is moving stuff, right? And you put these sensors on your equipment. What kind of value proposition can you get out of it? Anybody from the group?
Yeah, so we have two things. So one is we will be able to eliminate the third-party outsourcing outsourcers, so that manufacturers directly sell it to the customers. So that way, the manufacturers and customers are getting the best. That is one option. The other option is like, but yeah, the third-party outsourcing contractors, they could place the sensors on the machines, and thereby they can they'll be able to know much better detail whether when customer requires 3 cranes or 2 cranes, or also know when.
Okay, so there are two value propositions coming out of this. Very good, actually, brilliant. Because one of them is saying, which is actually transforming the industry. This is real. This is happening. Manufacturers are now starting to realize that they can directly engage with the customer, and the sensors are giving them better insight into service and into maintenance, and they don't need to have a third-party reseller and servicer in the middle who's actually buying from the manufacturer and is responsible. So like Johnson Controls, Siemens, a lot of these companies are rethinking the way they have engaged with their customers in the past. With IoT data on these devices, they can directly engage, directly service, and the subcontractors or the actual maintenance crew who's going to go out and fix something can be tapped directly with that sensor data, and whenever something is down, they can directly go and fix that, dispatched by the manufacturer. Not only that, with the usage, they have now better insight into how the customer is actually using the crane or the forklift. They can bring that input into their product design, into improving their product, or creating specific types of cranes for a specific type of customers, or a specific type of forklifts for a specific type of usage. So the product manufacturing is now getting real input from actual usage in the field, which they can now incorporate into their engineering and product innovation perspective. So this is actually happening, and this is going to dramatically change how companies build products and how they deploy and service those products on behalf of their customers. Very well.
And also, the routes are also actually optimized, like, because we know the location of the forklifts.
Correct. So the maintenance crews routing can also be optimized because you know exactly where the forklifts are, where the cranes are, which ones need maintenance, which one needs replacement parts. So you have a much more granular information into your. So instead of sending someone, go there, oh, okay, it's that broke, I don't have this equipment, I need to order that. Go back 2 weeks later, come back again. So you can optimize each of those business processes in helping your customers. Yes?
So when you have sensor information, instead of buying all the equipment out front, you would also stagger it in cycles, say 1 year or 2 years.
So the usage information is, when you put sensors on the equipment, the usage information is useful for the customer, and based on that they can actually decide. Previously they were like, oh, we need 3 forklifts. Well, why do you need 3 forklifts? Look at this usage data, all of them are underutilized, you can probably live with 2. You don't actually need 3. So again, going back to operational excellence and optimization. All right, last group, just 2 minutes, we'll quickly wrap it up with sensors in cars, reporting on driving activity. How does that add value to insurance?
So we came out with the 4 value propositions. Number 1 is with information about the location, driver's profile, insurance can calculate the probability of person getting into accidents, and accordingly charge the premium rather than standard.
So first value proposition is with exact location data, you can actually figure out whether they are in busy traffic all the time, they are in the insurance companies have access to a lot of historic data on accidents and damages or break-ins, theft, stuff like that. Now when they actually know where the customer is, they can actually improve their pricing strategy. If you live in a safe neighborhood, or if you drive safe, or your driving pattern doesn't match or typical accidents, then you should be charged a lower premium. And companies are doing that. A couple more?
The second one is they can give a value advantage to the customers. Like they can give them a warning in this month, this area, chances of accidents are high. These are the reasons.
So again, location based, they can give you a price comparison. They can tell you drivers who behave this way, drive this much. This is the profile that gets this kind of pricing. So now you have an incentive to change your behavior in terms of driving, in terms of how you interact with your car, and then you know that your insurance is automatically come down. Right now it's a black box. So customers actually don't know how much the rates are going to go up or how much the rates are going to go down. So I'll stop at that, and apologies to the next speaker for running over a little bit, but I hope you guys enjoyed it. Once again, thank you for showing up on Sunday, and I hope you